Hello everyone, in today's video we are going to be looking at simple and compound statements. So a valid statement is a declarative sentence that's either true or false but not both. So for example, something like the sky is blue. It's a sentence that is either true or false, it can't be both. And so we're going to look at these simple statements and I want you to tell me if it is a valid statement or an invalid statement. So for example, today is Friday. I'm not asking whether it's true or false. Is it a valid statement or not? And this one is a valid statement because it can be true or false. Welland is a city is a valid statement. Open the door is an invalid statement because it is not true or false. It's, commanding somebody to do something, so it's not a valid statement. Did you open the door? Is also invalid because, again, it's a question. It's not a statement that is true or false. Now, simple statements are statements that express a single idea. So, for example, today is Monday, I went to class, the sky is blue. Those are all one single idea. A compound statement combines two or more simple statements. So, for example, if it rains, then the ground will be wet, the sky is blue, and the sun is shining. Both of these have two or more ideas in them that are then connected by a connective. So for example, we could say, it is raining, the ground is wet. Those are two different statements I've then combined with an if-then connective. The sky is blue, the sun is shining are two separate statements I've combined with connective and. We can use math symbols and connectives to write these statements in symbolic logic. And these are the five main types of connectives. So we have conjunction, which is our and symbol. It goes like this, and it means P and Q. Disjunction is or, and it uses this symbol, and we do P or Q. Negation or not is using this symbol. It would look like this, not P. And then we have conditional and biconditional. Conditional means P implies Q. So here is the math symbol we use. It's an arrow. For example, we could say something like, if I study, then I'll pass the test. So if you study, then that implies you're going to pass the test. Biconditional is P if and only if Q. So P is true if and only if Q is true, right? And it uses this double arrow here. So let's look at some examples by writing different sentences into symbolic logic. So for example, today is Friday and I have one class. So we first have to write out what those statements are and set them equal to a letter. So for example, I can say P is going to be today is Friday. And Q is going to represent I have one class. And I'm going to use the connective and here to combine them. So P and Q. So this is my symbolic logic, and I have to have sort of a legend on the side to show what P and Q represent. Okay, so you tried this one. I played video games or I went to class. So try this one, pause the video, and then start it up again when you're ready. Okay, so again, we first have to do our legend. I'm going to say P is I played video games, Q is I went to class, and I'm connecting them with or, so it's going to be this symbol here, P or Q. So I want you to try this one. Today is not Friday. How would I write that in symbolic logic? Okay, so my statement is going to be today is Friday, and I'm going to use the not with this symbol here. So not Friday. Today is not Friday. Now, if we want to get a little bit more tricky here, I can say if we get wet, then it is raining. So try this one out. Okay, my answer key is going to be we get wet. and it is raining, and P is implying Q. If we get wet, then it is raining. Let's add in another one. If we are outside and we get wet, then it is raining. So try to write this one in symbolic logic. Okay, so we have three statements here. We have, we are outside, we get wet, it is raining. So we are outside and we get wet, then it is raining. So we are outside and we get wet, then it is raining. Now I want you to try this last one. If we are not inside and we get wet, then it is raining. Okay, so we're going to have a we are inside as our statement. We get wet, it is raining, and so my symbolic logic becomes not P and Q implies R. We are not inside and we get wet, then it is raining. Okay, so there's your introduction into statements, valid statements, simple and compound statements, and how to write those statements in symbolic logic. In the next lesson, we are going to be looking at truth tables in order to take these statements, some really complex statements, and follow them through to see whether they are a valid statement or not. So for my Niagara College students, again, I want you to think about how you've done across this video. If you are the sad face here and you're feeling really lost, then you're reaching out to me to get some help. If you're thinking, okay, I need a little bit more practice, then you're looking at the exercises on Brightspace. And if you're good to go, then you might want to try just a few to make sure that you remember for next lesson and prepare for our next lesson on truth tables.